Part 3 of 7.1. We're going to look at this last example, and we're going to look at some different possible ways of solving it. So we're going to find the area of the region bounded by y equals x minus 1 and y equals x minus 1 cubed. Again, we need to find the points of intersection. So one way to do that, again, is set these two equal to each other. Multiply this all out. All right, we'll alter that here in a second. So if I wrote this out 3 times and FOILed it and go through all that work, there's my answer. Set it equal to 0 and start factoring. Factor out an x, trinomial factors to x minus 2x minus 1 equals 0. My answers for x are 0, 1, and 2, which creates the point 0, negative 1, plugging it back into this equation here. 1 minus 1 is 0, 2 minus 1 is 1. So there's those 3 points. Okay. Now, another way to approach this problem, let me grab my iPad here, is you do not have to FOIL that all out. There is a shortcut for doing that. So let me put this up here. I'll try to make it as big as possible so you can read it. There we go. So what I can do with the x minus 1 raised to the third power is equal to x minus 1. Notice that both set of parentheses are exactly the same. So we could let x minus 1 equal u. If I do that, this now becomes u cubed equals u, or u cubed minus u equals 0. Factor out a u. Difference of perfect squares, or just go ahead and solve it. U equals 0, u squared equals 1, u equals plus or minus 1. Take these answers, plug them in over here, and resolve it for x. Okay, so we'll put in the 0, then x equals 1. We'll put in the positive 1, x equals 2. We'll put in the negative 1, x equals 0. And you can get the same 3 answers for x with the less work of having to multiply this all out, doing all that FOILing. All right, so just keep that in mind. Whenever you see binomials that match up the same, you can simplify your work. All right, so we're going to plot those 3 points. Graph that line y equals x minus 1. Draw in our curve here, which is a cubic curve, which has been shifted 1 to the right, so it looks like this. And now we have to find the area between 2 different sets of curves, if you will, because we're blue curve over red curve over blue curve. So we have 2 different integrals to create. So we'll go x minus 1 cubed over x minus 1, and then x minus 1 over the x minus 1 cubed. Subtract those 2. Now again, you could go ahead and factor this out. We can do some u substitution. All right, you don't have to FOIL this out. You could if you wanted to. It's just more work. All right. So if you integrate x minus 1 to the third power, that'll be x minus 1 to the fourth power times 1/4. And then you take the derivative of the inside, which is just 1, so you don't have to worry about dividing by 1. It's kind of like that chain rule concept when you did derivatives. Our minus x becomes x squared over 2, or negative 1/2 x squared, and then plus 1. And then we'll use those same rules over here, just watch your signs. X becomes 1/2 x squared, minus 1 becomes minus x, minus, and we'll just bring this over to here. Substitute in our values. Plugging in the 1 is going to give me 1/4 times, wait, that's a 0, done, 0. 1 squared is 1, that stays minus 1/2 plus a 1. minus, put in the 0. That'll be negative 1 to the fourth is 1, so 1/4. This is a 0, this is a 0. Plus, upper limit goes in. 2 squared is 4 times a half is 2. Minus 2. 2 minus 1 is 1 times the fourth, minus 1/4. Minus the lower bound. 1/2 minus 1, then 1 minus 1 is 0. So this will be 1/2 minus a fourth minus a fourth. And then we'll have minus a negative 1/2, which is plus 1/2. Well, we'll get this to all cancel out. 1/2 minus a fourth is a 0, so 1/2 units squared. All right, now a second approach, you might have noticed this. Notice that because the cubic curve is symmetrical here to the origin before we shifted it, and so is this line shifted one to the right, these two regions represent the exact same size and shape. So you could have just taken one of these integrals and then multiply it by 2 and still come up with the area of 1/2 units squared. All right. Again, you could also do the u substitution here in integrating, because you could have called this u cubed minus u and integrated it that way in both cases. And then with your u substitution, the derivative of x minus 1 is just dx, and the derivative of u is just du, so it's just a clean swap out. So again, find those shortcuts when to use them.